All right, so we are going to start. We have a couple problems I wanted to do related to um, scale factors that we talked about last time. I wanted to do a little bit more with that. So let's try this problem. All right, so for this one, I'm going to do it kind of the longer way first, and then try to explain scale factors again, like through that to just show you how to save time. Um, so the first off, if we have this square R, it says it has side length 15. And then we have this square S, which is bigger. And this is saying, since it's a square, this means these are all 15, which means the perimeter would be 60. And then it says the perimeter of square S is 3 times this. So if we multiply that by 3, that gives us 180. And then we want one side of square S. So all four sides are the same. So if we divide this by 4, we would get 45. So all the side lengths will be 45. All right. So the answer to the problem is 45. But like I said, there's a quicker way to get that by using what's called a scale factor. So the scale factor is, I'll call K. It's the value that we multiply any single dimension by. So they're telling us it right here. Perimeter is considered single dimension. We are multiplying by 3, which just means the 15 gets multiplied by 3. So we can get 45 without doing all this work. We can simply get it by just doing 15 times 3, because 3 is the scale factor. It's what every single dimension is being multiplied by. Okay, so let's try 2. This one's, they'll get progressively more difficult. But again, try to locate. The goal is to try to figure out what the scale factor is, and then that'll, in this case, it'll allow you to find the area. All right. So usually in these problems, what I'm trying to do is identify what this thing, the scale factor is. So it says the second triangle has side lengths that are 8 times those of the first triangle. So that means the scale factor is 8. Each dimension of the small triangle is being multiplied by 8 to get the dimension of the larger triangle. And then if I want to know what's happened to the area, that is always whatever k squared is. So if each side gets multiplied by 8, the area will get multiplied by 64. That's the whole concept here. So the area of the second triangle, so if it started at 14, we're just going to multiply that by 64. So that is 896.
Can you explain how we get the k squared again?
Mm-hmm. So just in general, whatever the scale factor is it I'm just going to call k. It's usually what they call it in a geometry book. That is what each side length gets multiplied by whenever you're going from, like, let's say the smaller figure to the larger figure. Anytime you want to know what the area gets multiplied by, that will always just be k squared. And when we get to it, we'll have some volume problems that will get multiplied by whatever k cubed is. So, for example, let's say, I'm just going to make up numbers with triangles just to kind of show you the shortcut here. Let's say this triangle was base of 2 and height of 3. If we remember, again, the reason that this way is going to be quicker is because we don't need to know any of these formulas, but we do need to know for other problems. So if we wanted the area, that would be 1/2 times base times height, which is going to turn out to be 3. All right, so the area of this triangle is 3. And then if the side lengths get multiplied by 8. Again, I know it's not 14, but I'm not worried about that right now. If everything gets multiplied by 8, then this one becomes 24. This one becomes 16. And if I want to find the area, it'd be 1/2 times 16 times 24, which is 12 times 16, which is 192. Right, so this would be, again, like a long way of figuring out that the area to go from 3 to 192, it got multiplied by 64. So instead of going through all that to figure out that the area gets multiplied by 64, it's just a concept that if each side is being multiplied by 8, no matter what shape it is, the area will be multiplied by 64 just because 64 is 8 squared.
Okay.
I have a question.
Yeah.
So when it comes to volume and scale, I know it might be like a little bit too ahead, but I was wondering when you get there, or if you could do it right now. I don't know which way you prefer. Could you explain it like how you did with the area,
Mm-hmm.
conceptually?
Yeah. So here, I'm
Yeah.
just going to put in a blank page. So let's take, for instance, like a rectangular prism. Where we have the volume is the length times the width times the height. And then I'll just make kind of a bigger one. Okay, so I'm just going to make up numbers for this first one. I'm going to say 3, 2, and 4. So that means the volume of this first one is 24. And then I'm just going to choose, I'm going to put it over here, that K is 2, which means every side is going to get multiplied by 2. So in my bigger rectangular prism, 3 goes to 6, 2 goes to 4, and 4 goes to 8. So I doubled every side. The long way of doing this would have been finding this volume and this new volume. So 6 times 8 times 4 is 192. If we wanted to see what the area got multiplied by, doing it this longer way would be 192 divided by 24. That would give us 8. So I think I said area, but I meant volume. So the volume got multiplied by 8. So 24 times 8 is 192. A much quicker way would have been to disregard pretty much all the numbers in this problem. If all we knew is that the scale factor was 2, meaning each side got doubled, the volume would get multiplied by whatever K cubed is, because cubic is volume, and 2 cubed is 8. So the point of it is to essentially save time and not need to worry about the actual formulas. As long as they're similar figures, they can have separate questions where you absolutely need to know the volume of a rectangular prism or a cone or any ones that are given on the formula sheet. But if they are similar figures, then you don't need formulas. You just need to figure out what is the thing being multiplied by. And if it's volume, I cube that. And if it's area, I square that. Does that make sense?
Yeah, totally. Thank you for the shortcut. I never really thought about it like that, but that makes sense.
Yeah, good. Okay, so now let's try to apply it to a volume problem. So try this one. Okay, so this one's harder because we have to kind of work backwards. So I'm going to set it up like this. I'm going to say like height. Whoops. Okay, so I'm going to do the volume first, and I'm going to put the 64 first. I like to work smaller to bigger so that I don't have to deal with like numbers less than 1. We can do it at any order we want. So the volume goes from 64 to 1,000. And the height goes from unknown, put a little question mark there, to 4. Because the one with a volume of 1,000 has a height of 4. So the way this works, again, in general, is that the height would get multiplied by whatever k is, and the volume will get multiplied by whatever k cubed is. So that's, again, the concept that we just went over. So this is what, at this point, we just have to this is what we have to know, is that any single dimension gets multiplied by the scale factor, and volume gets multiplied by scale factor cubed. But the way this problem's set up, we can't find k right away, but we can find k cubed, because we can just do 1,000 divided by 64, and we get this. So the volume was multiplied by 15.625 to get the new volume, which tells us that's k cubed. So I need to take the cube root of that. So if I do that, I get 2.5. So that tells me that the scale factor is 2.5. This is why I like to set it up this way. Now I can see that I need this would have been a smaller number that got multiplied by 2.5 to give me 4. So I just work backwards by dividing. So the answer is just 4 divided by 2.5, which is 1.6.
I just have to say, like, I almost got this right, but honestly, when I divided it and I got 15.256 and the 2.5, it didn't seem like the right answer, so like I ignored it.
I know,
But now
yeah.
that I see it, it looked really weird. Like it looked really weird.
No, I double checked too. When I got 15.625, it is strange, but you have calculators, so you just got to keep going with it.
Can you explain why it gets divided by the 1? Sorry, by the 4 gets divided by the 2.5.
Yeah. Do you see where I got the 2.5 from?
Yeah.
Okay. So it's just as simple as, like, I could even think of it as an equation. So like instead of the question mark, I could just think of it as like the height. So the height of the smaller one was x. And then that x got multiplied by 2.5 to then eventually give me the 4 of the bigger one. So solving this equation, I just divide each side by 2.5.
Oh, okay. Thank you.
All right. So yeah, I like to always just, if you're in a geometry class and like they decide which figure is, like, it's called like the image and the pre-image, then the scale factor could be like a number less than 1. But we don't have to worry about all that. I would just always think of the first figure as the smaller one. And then you're always multiplying from the smaller one to the bigger one. So if you're going from the bigger one to the smaller one, you're dividing. Okay, let's do one more of these. This one includes both volume and area. Okay, so I'm just going to set this one up kind of like this. We've got, like, this one gives us area and volume. So if I organize this, like, so the volume went from 125 to 216, and the area went from, the area of the smaller one's 25 to, again, unknown. So I know always that volume gets multiplied by k cubed, and area always gets multiplied by k squared. So with the given information, I find k cubed first. So 216 divided by 125, again, you get a weird number. You get 1.728. But we need to find k if we're going to find k squared. So we do the cube root of that, which is 1.2. And then we square it to get what the area was multiplied by. So that's 1.44, yeah. So now in this problem, to find the new area, we have the smaller one, we're just going to do 25 times 1.44. and that gives us 36. And this is considered a very hard problem. You can see the work in it's not the hard thing. It's just knowing to do this and not having to use, typically you read cones, you go right to the formula sheet and you're looking up the volume of a cone, but you don't need that for this. And the word similar is what tells you that you don't need a specific formula. What you just need to do is be able to figure out what the scale factor is. So the given information gives the scale factor cubed, cube root it, and then you need the scale factor squared to find the new area. Okay, do we have any questions on that?
No.
Okay. All right, so that was what I had for scale factors. And then I had other problems that were emailed to me. So that's what we're going to do the rest of the time. So these don't really have a theme. They were just a bunch of different problems that I got sent. I think a lot of these were from some Bluebook tests. So let's take a look at number 5. Okay. This one does not have a lot of work to do, but it has a very common mistake. A lot of students think because we see a percentage that it has to be exponential, but that is not the case here. So if we just kind of make the equation, so f of x equals 201% is just the decimal 2.01, and of is just multiplication. So this is literally just 2.01x. And this is a linear equation. It's in the form y equals mx plus b. So since it's just a number times x, it's increasing linear. If it had said that we're increasing by 201%, that's what would create an exponential function. And there are many problems where percent increase and decrease are modeled by exponential functions, but this is not one of them. So I know a lot of times we see things and then we make generalizations. So I know on this one, C is a common wrong answer because of the percentage, but you just got to be careful. It's not increasing by the percentage, it's the percentage of, which actually means that it's linear. All right, any questions on that one? Okay. Okay, here is another one. This is an example of has a lot of information and there's only one number that's important. And it's just, you have to know what a frequency table means. But this has no work to do. It's just one thing you have to look at. Okay, this one is just, we have a frequency table and it wants the maximum data value. So the maximum data value is just down here at 14. There's no work to do here. This one is just about understanding what a frequency table is. So it just means that there's the data, if it were listed out, there'd be 3 6s and 3 7s and 8 8s and so on. So the largest value we would have is just 14. Okay, so again, not like a difficult problem, but I think someone sent this to me because again, it might just be you haven't seen a frequency table in a while, and it almost seems too easy to be a problem, but they definitely have these. Okay, any questions? Okay, then let's keep going. All right, this one's a little harder, so try this. Okay, if you're able to just figure this out, then great. But if not, then one option here is to where you kind of just choose your own value. So if 1 gallon can cover 170 square feet, an option is to just say that the number of square feet in the fence is 170, because then we would just need 1 gallon to cover it. And then it says which equation represents the amount needed to stain it twice. So just logically, if I choose 170, then my answer should be, I should need 2 gallons. And when you plug in 170 to all the answers, D is the only one that gives you 2 gallons. So that's the answer. So for me, when there are these like word problems where they don't give you a specific like value, sometimes just choosing your own value makes it a lot easier to figure it out. And in this case, I felt like 170 was the easiest value to just like figure it out.
I still don't understand how you get D.
Because so if I just choose W to be 170, then that's the total surface area of the fence. And they're telling me that I need 1 gallon to cover 170 square feet. But the question says what's the total amount needed to fence this yard twice? So I would need 2 gallons to cover the yard if I make W equal to 170. So I need my answer to be 2. So if I plug in 170 to all of these, 170 divided by 85 is 2.
Oh, okay. I get it.
So again, that's just an option. You might be able to figure it out logically, but if sometimes that's a little more difficult. Even I personally would probably have just chosen values to do this problem. The mistake is probably students choose A because this thing at the end. They do this all the time on the SAT. They just like at the very end they ask a different question. They want to just randomly stain the fence twice. So just pick your own value, figure it out logically with your value, plug your value into all the answers and see which one of those gives you that exact same answer. Okay, this is definitely a harder problem. It says it's question 20, so I would imagine it was the last question of a hard section. All right. Typically, if there's a word problem related to a quadratic function, I want to do this in Desmos. I'm going to show you how to do that. But before we jump over to Desmos, we've got to know we're going to use a Desmos table. And when you do a quadratic using a Desmos table, you need 3 points. If it's linear or exponential, 2 points are fine. For quadratic, you need 3 points. So it says that the function is after a certain amount of time, it's how far below the surface of the water you are. So if the seal entered the water, we can assume that there's going to be the point 0, 0, because when they entered the water, the surface of the water is 0 depth. And then after 6 minutes, it's at 302.4 meters. And then after 12 minutes, it reached back to the surface. So those are the 3 coordinates that I can kind of take from that. And rather than writing the equation and doing all that work, we could just use Desmos. And let's remember, we're going to try to figure out what the depth is after 10 minutes. So let me show you how to just do that really quickly in Desmos. So you add a table, and then I'm going to put those values in. So 0, 0, 6, 302.4, and 12, 0. And then you hit this up here on the left, you do add regression, but change it. The default will be linear, so change it to quadratic. And then here's 2 things that I would do. If you just hit this little button here, it puts it here. And then change it to f of x. And then right below that, just do f of 10. And then it just gives us the answer. So Desmos will take the points, give us the equation. If we rename it f of x, then we can easily plug 10 into that, because that was the question, was just what is it after 10 minutes? So the answer to the problem is 168. Again, multiple ways to do it, but this I think is a quick way to use Desmos. So I wouldn't spend a lot of time writing any equations of anything. If it's linear or quadratic or exponential, you can usually use this table. Okay. Any questions on that?
Um, how would you go about like finding questions like these and like getting used to using Desmos? Because like uh knowing when to use Desmos isn't exactly like intuitive to me yet.
Mm-hmm.
Like I don't exactly know when to use it, when not to use it.
Yeah, I mean, you just gotta. I mean, it's just about doing practice problems. Do you know about one prep? Do you know what one prep is?
No, what is it?
Okay, let me show you. Yeah, so if you go to it's one prep.xyz, and it's this completely free like question SAT question bank. And it's just a whole bunch of problems from College Board and Princeton Review. And then you could like find any type of problem. So you could do, I don't know if they have quadratics as a topic, but I'll show you what I did for the area and volume. I just clicked on area and volume. I don't know why it's so slow, but and then it'll take you to a bunch of questions. And there's 64 questions that it has on area and volume. So this is a place to get problems that are free. And you can find them by any question type. You could also do like the difficulty. Oh, that was only 64 because I had medium and hard, but so there's more than that. So that's just a place to find a bunch of problems. And other than that, it's just, I mean, again, like that's stuff that I could kind of go over even next week, just like when to use it, when not to use Desmos. Because on a lot of problems, there's like using Desmos can be quicker, and some problems it's kind of wasting time. Um, but the only real way to get a feel of that is to just like do problems and just see how quickly you can do it, but using Desmos and then not using Desmos. Does that make sense?
All right, thank you. Yeah,
Okay.
yeah,
Yeah.
thank you.
Yeah.
I think I'm probably gonna spam some of those questions, one of the categories, and just see um how I can figure it out.
Yeah. I mean, definitely it's going to be more of the algebra and advanced math is going to be Desmos. You don't use Desmos quite that much in geometry and trig and not that much in problem solving. So I would do a lot of the algebra and advanced math and see like how you can use Desmos for those. Okay, so this one was the final answer for this one was just 168. Okay, all right, let's try number 9. All right, this one is hard because they give you a lot of information that you don't need at all. So if we go to the question, it says if P% of the daily allowance of potassium is provided by X servings per day, then which of the following expresses P in terms of X? So all we need to know is that each serving is 5% of the daily allowance. Like all this stuff back here is not important. Calories from fat, total calories, serving size. It just wants to know if we have X servings. So this is another one where I think I would like choose a value to try to figure out which answer makes the most sense. So for instance, if X were 2, and 1 would work here, but sometimes we like to stay away from choosing 1 because a lot of answers might give you the same thing because 1 is kind of like a special number. So I just skipped over that. And if I think about it, if there's 2 servings and each serving is 5%, then that means the daily allowance is going to be 10%. So P will be 10. And that's it. So from there, you can see that B has to be the answer, because if I plug in 2, I have to get 10. And I think the mistake on this problem is trying to use like the decimal form, but when it said P%, so like P itself should have been like a whole percent, like not in decimal form. So it's kind of why the other answer, anyway, 0.5 is 50% to begin with. And 0.05, at least they represent 5%, but they're wrong because it doesn't want us to convert to decimal. It just wants, like, if the answer is 10%, then P is 10. So it's another one where there's not a lot to do, but it's a hard problem because they do a lot of confusing in the beginning with a bunch of different numbers that are just not important. All right, questions on that one?
No.
Okay, so here. All right. So this one, we have to add these percentages up because the remaining, we need to know what percent these remaining are. So if you add up 15, 45, and 25, you get 85%, which means the remaining is the 15%. So these 6 individuals represent the other 15% of the population. So the way we can do that is 0.15, which is 15%, times X, where X is the total number of people, is equal to 6. So 15% of the total is 6. You just divide. So this tells us that X is 40. So that's not the answer, but that just tells us how many total people are on this committee. Now, a little bit of a shortcut we can do is how many more teachers were invited to join than school and district administrators. Well, 45% were teachers and 25% were administrators. So the percent more is 20% because 45 is 20 more than 25. So that means there was a 20% difference. And all we have to do is find 20% of 40, which turns out to be 8. And if that doesn't make sense, you could just find 45% of 40 and 25% of 40, and you'll see that it's 8 more teachers. But you can do a little bit of a shortcut there because you don't need to find both. You just need to find the difference, which is 20%.
Could you re-explain the 0.15x equals 6?
Mm-hmm. So there's basically 4 groups of people here. There's parents, teachers, administrators, and students. And since they are all the different types of people that could be part of this committee, that has to equal a total of 100%. So these 3 that they give us adds up to 85%. So 100 minus 85 is 15. So that means the students comprise of 15% of the total. Well, 15% of the total was 0.15 times X, where X is the total, and that equals 6. So I just solved that equation by dividing. That give me the total of is 40. Because if you do 15% of 40, you'll get 6, like these 6. Does that make sense?
Yes. It makes a little bit more sense, but I figured out like the 15% are students. Um, but I didn't get the same exam like answer because it just didn't click to me that it kind of like multiplied times something to get the 6 students.
Yeah. Yeah. So
So like I couldn't figure out the total amount of people.
yeah. So that's the thing. You want to just think about, like, I guess what you would do if you did know the total. And you would do like the percent in decimal form times the total. It's just, since we don't know the total, we just make it X. So it's just kind of coming up with it's called like a percent equation. Like the percent times the whole equals the part. It like looks like this: percent times the whole equals the part. That's called the percent equation. That if you learned it, would have been a while back. It's usually like in pre-algebra, so it's probably been a while. But that's kind of where it comes from. Okay, we have time. Let's do one more. Okay, so I would probably set this one up. So it has 6 rows of birch trees. So let's remember there's 6 of these and 5 rows of maple. Each row of birch has 8 trees, 20 feet or taller. I'll call them 8 tall trees, and 6 trees that are shorter. And the maple trees have 9 that are tall and 7 that are short. So now we want to look at a tree from one of these rows will be selected at random. What's the probability of selecting a maple tree given that the tree is 20 feet taller, 20 feet or taller? So it means we're only looking at tall trees. So when they say given, it means you're ignoring everything but those. So what we do is the number of tall trees, we got to remember there were 6 rows of birch. So the number of tall birch trees is 6 times 8. So that's 48. Plus the number of tall maple trees is 45. All right, so just again to recap, given that the tree is tall, we only care about the tall trees. So 6 rows that have 8 tall trees each, 5 rows that have 9 tall each. So whatever 48 plus 45 is, which we can do pretty easily, that's how many tall trees there are total. And then what's the probability of selecting a maple? Well, the maple was 45. I think this, I took these from the wrong thing. So ignore this. It's supposed to be open-ended. Those answers don't even make sense because probability should have answers less than 1. So just ignore them. I think I accidentally screenshotted multiple choice from another problem. So the answer, so 48, so it's 45, and then 48 and 45 is 93. So it should be 45 divided by 93, which is 0.4839. So we need the total number of tall trees and then just the number of tall maple trees. So that's what we're dividing the probability. So again, ignore these. So then if we give 5 characters, it would be 0.4839 if we round appropriately.
I have a question.
Yeah.
Can you write 4, 5, and then /9, 3? Do you think it will still take it?
Oh, yeah. Good point. So yeah, definitely, because this would
9
be,
characters.
it'd be
And
5
5.
characters. Yeah. Or
Okay.
you wouldn't obviously write it like that. It would look like this on the actual test. Yeah. 1, 2, 3, 4, 5. Yeah. Good point. I would have actually just done that. This would have been wasting time. So yeah, good point.
Okay.
If your
Okay.
fraction is reduced, then yeah, just do that.
So it's maximum 5 characters, right? If it's more
Yes.
than that, then you would have to change it to decimal.
Yes, that is correct.
Okay. Thank you.
Okay, then we can stop there. So thanks for coming. And as always, I will send out the email with the link to the recording and the answer key to this.
Thank you.
All right, you're welcome. I'll see you hopefully again next week.
Have a nice day.
All right,
too.
thank you. Have a good
All right,
night.
you're welcome. Bye.